Hi, everyone. Thank you so much for attending this session. I'm Emmanuel, co-founder of YShade.ai and head of AI there. And I'm excited to be sharing with you the work we've been doing leveraging PyTorch to build computer vision algorithms for all skin shades, particularly 100 skin shades. So a little bit about me. I did my graduate studies at the University of Notre Dame with a thesis in the emphasis of the intersection of AI and directed energy weapons. If you don't know what those are simply large laser guns, right? So that's what I did my master's thesis in. So if you want to have a conversation about anything related to that, I would sure love to have you with me. Yeah, and I love teaching how to deploy models. I have a few courses on Coursera for a couple of years now. Did a few stints at Morgan Stanley building ML models for the financial advisors. And over the past 4 or 5 years, my co-founders and I have been building YShade.ai, right? And for those of you who've been attending conferences, if you went to CVPR or NVIDIA GTC, you might have seen us demonstrate our algorithms over there. So what YShade.ai is simply a company that builds computer vision algorithms for the beauty and then the fashion space, right? So we've been able to curate a custom data set of 12 million images that we build together with a variety of estheticians and makeup artists. And on top of that data set, we've been building both predictive algorithms and also generative algorithms. And the way we built that custom data set of the 12 million images, like I said, is working closely with makeup artists and estheticians, defining the scale of the human skin shade range, right? So for those of you who are familiar with human skins, there's a scale called the Fitzpatrick scale. That is, I think, around 1 to 10 shades. Anyone who wears makeup knows that that is not enough, right? So working closely with makeup artists and estheticians, we expanded that shade range from 10 to 50 and then finally to 100. And with this data set that we built, we cleaned and labeled them across 100 skin shades, right? So 100 labels, taken from the 1 all the way to 100, with 1 being the light porcelain skin ever, and 100 being the deepest dark shade that is currently available on Earth right now, and everything in between, right? So everything from fair skin, porcelain skin, olive skin, medium skin, dark skin, and deep skin. That 100 shade range covers all of that. And to do this, we used a lot of Python data pipelines. At the end, you can ask me more about that and I can dive into it. But we built our own custom data pipelines. As you can tell, 12 million images is a large data set, right? This is not something that one engineer, which we have a very small team, can manually do. So we have a lot of data pipelines. But most importantly, we do everything in the cloud. The image here is using Google Cloud, but any cloud could be used. But we leverage Google Cloud mostly for their cloud storage and also for the data processing. So yeah, I put examples of what our images look like. The 12 million images contain augmented images as well too. So for the use case that we use, our customers are not always using the right angle of images, right? They use different angles. So we account for all of that by augmenting that data set. But 12 million is really large. You should see our Google Cloud billing each month. And what we've done, like I mentioned earlier, we build predictive and then generative AI algorithms on top of this data set, right? So for the predictive algorithms, for those of you who wear makeup, the easiest thing we do is to shade match for foundation, for skin tint, colors, for powder, setting powders, etc. Right? So those are the predictive. Like, hey, your shade 58, your shade in Fenty Beauty is 230, and this product would also the other products you can find your shade in L'Oreal, ColourPop, etc. So that's what the predictive does. The generative, right, as you've probably been hearing about the expansion of Gen AI right now, is mostly used in trying on most of the products, right? So an example is the virtual hair try-on that we have. So this is me in the Bantu hairstyle. And so that's what we use our generative for, right? So you can do text to image generation and also to try on things like lipstick, lip liners, etc. So that's what the data sets, that's what the algorithms you use for the data sets include, right? And I think a cool thing is we're able to help a few companies, right? Some of them are Nude Bar, where they help users find the right shapewear. So for those of you who don't know what shapewear is, think of Kim Kardashian's skin. So shapewear has a variety of skin tones, and the trouble they were having was that a lot of people were returning the products after they bought it because it wasn't matching. And shapewear isn't like other fashion articles where you can just, people can return the items and you can sell it to another item. So the whole recycling process is tedious, right? So using our algorithms, they're able to identify the right shade all online, get the right product, and then get that over, right? And also for the generative, trying on, for those of you who wear lipstick, nude shade of lipstick, which is very different for every skin tone, right? So every company has a nude lipstick, but myself, like dark skin that I am, nude on me is very different from like a fairer person, right? Nude on them, but every company labels that nude. So we're able to help a company called Kiblawi develop algorithms that matches the perfect nude for each of their customers. And we've been able to do all this with PyTorch, right? So before I dive into how we built it in PyTorch, why we decided to go to PyTorch, right? There's so many deep learning frameworks, and we have tried all of them. The reason we did it was easily because PyTorch is built with Python. I know it sounds like now there's a lot of positive press around Python, but for a while, a lot of people spoke very negatively about Python, right? A lot of engineers and developer advocates were very negative towards Python, but we love Python because it's really easy to develop in, because we have a very small team, right? We can't afford to have complex systems, so Python makes it really easy and everything's streamlined, and that's why I love PyTorch. The second one is the support for CPU and GPU, right? Again, we're a very small team. We don't have a ton of money, right? We don't have endless amounts of GPU. So every time there's a new algorithm, we need to try it at a really small scale. Like, okay, would this work with, like 10,000 images, right? We want to try out like a new setting powder matching algorithm, for example. We need to try it out on 10,000 images. We don't need GPUs, right? Like I said earlier on, we do everything in the cloud, and cloud gets expensive. So we have to build it on a smaller scale using CPUs, little data, validate it, talking to customers, having users use it and try it, say, okay, this works. Then we can invest more infrastructure, more data, more money into it to scale it. And PyTorch makes it easy because you can always switch between CPU and GPU. And yeah, the last two are the easy deployment, right? Like I mentioned, our users are makeup artists. They are not really interested in APIs, right? They don't know how to, they're not calling APIs, right? They're using their mobile phone, they're using their iPads, they're using the websites that they go to, right? So we need something that we can easily deploy and then be able to inference across multiple platforms. So an easy example is we deploy across mobile app, web app, and also Google Chrome extension, right? But because we use PyTorch, we don't have to worry about, okay, we have to use like one particular framework for this platform and then another framework for that. That's why we really love PyTorch. And I think the last, but certainly not the least, is how incredible the community is. What we are building is very niche, right? I'm sure a lot of engineers here are thinking makeup, AI, right? We don't have a lot of people who are very interested in that intersection, the people who are really small, right? So sometimes we hit certain roadblocks that other people don't really hit, right? So if you're building something that a lot of people are interested in, it's easier to find help if you hit a particular roadblock, right? But if you're building something that is a very small niche, it's harder, right? But because of how supportive the PyTorch community is, it wasn't that way back in 2018. But now, whenever we do hit these roadblocks, we're able to find people who might not be working on our exact space, but in something similar that we can leverage their learnings from for the work that we do, right? So that is why we did PyTorch. And the way we did this is basically we started like every ML model deployment or development, we started building things in Colab. From our perspective, we decided to go with, again, this is not an advertisement, but we use Vertex AI by Google, mostly because of the Colab Enterprise and their workbench. We did that because, again, we don't have a lot of money to buy large amounts of GPUs, right? So we need a way to be able to scale our GPU needs without having to put up a lot of upfront cost, right? So that's why we went along with Vertex AI. The Colab Enterprise allows us to have a sustained usage of GPUs, and the same with the workbench. We can run things, over a week, over a couple weeks, without having to worry about, hey, if the GPU, our GPU usage is going to get cut off, or hey, we wouldn't be able to have access to particular GPU. So that's why we use that. Again, if we were to buy GPUs for 12 million images, it would be a really large cost, right? Even though the cost might be over, the cost might make sense for the extended use that we have. For us right now, we don't have that privilege, right? And also CUDA by NVIDIA, and then mostly Torch Vision, right, for model development. And the reason why we really like Torch Vision is because Torch Vision has a ton of pre-trained models, right? For us, again, as a small team, we don't really want to build everything from scratch. So having pre-trained models like VGG, ResNet, DenseNet, all on PyTorch, Torch's Vision's Python module, makes it easier for our developers to be able to, again, pull things out faster, build faster, deploy faster, right? And I think the thing that I think is a good thing is the Torch checkpoint. How do I put this? Because we train models for a very, very long time, sometimes we want to make sure that if, let's say, we are training a model, it's going to take about a week. We want to make sure that on the second day, we have a file that we can test on the third day, on the fourth day. That's how we do it, right? There are multiple ways to do it, but that's how we do it. And then the Torch checkpoint is really, really helpful for us in that sense. But even though after we've been able to train the model, we need to put out the model into the world, right? And again, that's what makes PyTorch really awesome for us. The easiest thing we do is to deploy it as a Flask API and then deploy it to the cloud. And with that, we can inference it for both our web app, our mobile app, and our Google Chrome extension. We have API development tools that I'm not going to dive more into, but even though our main customers are the fashion and the beauty industry, like solopreneurs and small-scale businesses who are just wanting things they can integrate into their websites and their mobile app, there are developers who are really interested in building things, especially in the gaming industry, that are related to human skin shades, right? So for them, we need to provide an API for them, and this all makes it really easier for us. But even though I've been saying that PyTorch is awesome, there are a few challenges that we have personally been facing, right? The most important thing is the backward compatibility. So for anyone who uses PyTorch, you realize that the more they add new versions, they degrade the older versions, and it's really difficult to find a version of NumPy that works with PyTorch 2.0.1 that also needs to work with, it's really very difficult for that, right? And as we have been deploying to the cloud, let's say you deploy to Heroku, Heroku keeps changing their Python stack. That means that if you build something, even if you containerize it and you're trying to deploy it to Heroku, you're going to face a few challenges, right? So that backward compatibility is really, really difficult. Model conversion. This is like a nitpicky thing to say, but when you save a PyTorch file, right, or like a torch model, like it saves at a .pth, right? And sometimes if you don't specify the .pth, it saves it as a zip file, and then you can load up that zip file, and then it works. But sometimes you want to use different forms of the file, right? So sometimes the model's file is too large, and you want to reduce it, and so you have to convert the file. So I think that is, again, it's a nitpicky thing, but yeah, it's a challenge. I think the most important, especially for our team, is the limited options for integration. And the main point of it is, in addition to these torch models that we deploy, we also have been experimenting with Llama, right? And for those of you who've been using Llama, I think it's awesome. And so how do you integrate like Llama with PyTorch? So if there's anyone who's ever figured that out really well, let me know. But it seems like it should be, right? Like, we should be able to integrate Llama with PyTorch models, right? That would be very helpful. So, yeah, that's about it, right? There's going to be a microphone at the back if you have questions. But yeah, this is what we've been doing. I hope you enjoyed the conversation. Please let me know if you have any questions.